Okay, so hi guys. One thing that I wanted to go over, give me a second. One thing that I wanted to go over is how many solutions would we know, or basically how would, you know, if we do have solutions to a quadratic function, how would they look like on a graph? So one of the things that I know is that so there's, for the first one, so solutions to quadratic functions. Okay. So one thing that I do know is basically that that we've already reviewed is the fact that any function with ax squared plus bx plus c is gonna look something like this. Okay, it's a parabola, and if a is greater than 0, it's up, and if a is less than 0, it's down. Okay, so one of the things that you have to know is how it would look like on a graph if we had a certain number of solutions. Give me a second. Okay, so for one solution, usually it would be a repeated root. Okay, so at x equals c, it would be x minus c squared, and the x-intercept would be at c comma 0 or x equals c. Okay, that's for one solution. For two solutions, and usually a quadratic always has two solutions. Sometimes the solution is repeated though, like this one is repeated. Okay. And then for, so then we have this other one where if we have one right here, this is at negative c, and then we can do the other one at let's just say at c. Okay, so basically it would be x plus c times x minus c equals y. Okay, the reason why I put plus c in it, because the reason why I put plus c and then minus c for the positive one is because when you do x plus c equals 0 and you solve for x, you get x equals negative c. So that's why over here x is negative c, and over here x is c, and then when you do x minus c equals 0, you get x equals c. So that's why I did it like that. This is for two solutions, by the way. Give me a second, guys, hold on. And then for no solutions, so sometimes if they ask you like on the for all real solutions, sometimes you get something like this, and this is like no solution, or it's imaginary. And I'll teach more about imaginary solutions later on. I first want to go over like the basic kind first. Imaginary, I feel like you can solve using basically any method, but it's like you have to, mostly for imaginary solutions, you have to do either the quadratic formula, or you can also do by completing the square, but you know, I don't think you can solve by factoring, but this is how it would look like if your solution is actually imaginary and it's not really, there is no x-intercept. So basically, like, because on the coordinate plane for xy, so one thing that I want to make note of is on the xy coordinate plane, imaginary solutions are not seen. Okay, they're not shown over here because they're imaginary, so we can't really see an imaginary. If you try to do, for example, if you try to say x minus I times x plus I equals y, this will not show up on graph, on xy graph, okay? Because it's imaginary. You can't really, imaginary means that we don't know where it is. It's imaginary. We can't really tell where it's gonna be. One thing that I want to make note of is the fact that the square root of -1 is I. That's the imaginary number I. But we're gonna go over those later on in another video because I barely want to introduce how they look like on the actual coordinate plane. Okay, so and then just to note, if c was negative, this would, and it was repeated, this is what it would look like. This is x plus c squared equals y. Okay, so I hope this somewhat helps. Basically, before I actually get into actually solving these types of equations, I wanted to kind of teach you guys. And usually when you solve a quadratic equation, you always make a quadratic equation equal to 0. I'm going to go over that more in another video, but I hope this somewhat helps. This is just a visual representation of how it would look like on a graph if you actually graphed, you know, x squared plus 2x plus 3 equals 0, or, you know, any function that, you know, if you basically graphed it, it would look in one of these ways, okay? So I hope this helps, and I will see you guys in another video, in the next video. Bye.